We are welcoming our next speaker, the author of the Kotlin for Apache Spark and big data developer advocate at JetBrains, Pasha Finkelshtein. Welcome.
Hello. Hi, everyone. Yeah, it's correct. My name is Pasha Finkelshtein. My surname is extremely hard to pronounce. You can refer me as Pasha or by my nickname, which is written here. You can follow me. You should actually follow me on my Twitter. I'm writing about big data. At least the English part of my Twitter is about big data and other tech things I think about. And I'm really developer advocate, or maybe developer advocate for big data at JetBrains. And that is why I'm here. I love data. And how did I fall in love with data? Well, 7 years ago, I was usual enterprise developer in a big bank in Russia called Sberbank. And Hadoop was like magic for me, some magic words. Everybody talks about it, and everybody's speaking about big data, Hadoop, Hive, or maybe something else. I'm not sure. I don't remember exact terms they have used, but it was all about big data, and I didn't even understand what big data is. So I started to look for data-related projects. Maybe not big data, but something more data-centric. And my next work was about working with DB databases like Presto, like something else, and maybe like Impala. And then at some point in time, I've moved from, team lead position in, some bank to the data engineer, linear data engineer, because it was very interesting to me to try to work with data, to work hands-on with my data. And what is the first thing data engineer learns? I'm not completely sure, but I know that Apache Spark is one of the most popular tools in environment of data engineers. You can use it in clouds, you can use it in on-premise, you can use it standalone or in cluster. It doesn't change anything. You should know Apache Spark almost everywhere if you want to be a data engineer. Of course, maybe at job interview you will be asked about MapReduce or concepts like that, but Apache Spark is a real thing which you will work with. Okay, and what did I have to work with Apache Spark? In my background, I had several programming languages like Java, Kotlin, Scala, Groovy, Bash, XML, YAML. Yeah, I'm not joking. Sometimes YAML is really programming language. It's kind of strange, but when you're writing something with Ansible, you're programming in YAML. And of course, I had sparse experience with some other languages. I've tried Haskell, I've tried Clojure, some esoteric languages. Just because I'm curious, I love to learn new things, and maybe one day I'll use them too. But my current love among other programming languages, Kotlin, and in this talk I will say why. And what did I have besides programming languages? I did understand core Java, like collections, concurrency, and so on. I had some understanding of garbage collection, which is quite important in big data. Sometimes garbage collection takes too much time during our Spark task execution, and that's one of the things we should be able to fight. I have lots of debugging experience. I mean, I worked with very old legacy projects. I've created new projects from the scratch. I've been writing some libraries, and you can find them at GitHub. I knew something about distributed systems. And here I mean that I know what CAP theorem is. I know what Q is. I know several network protocols like Thrift, Protobuf, and gRPC as RPC system. I know what REST is and what JSON RPC is. I know what Corb is, and so on. And I know thing or two about architecture. Well, any team lead, I believe, should know something about architecture. And this is knowledge which helped me to, to understand Spark more or less quite quickly without, preparing for half a year. Because its API, for example, data frame API is like Java Stream API. It's just for example. But the truth is, the supported languages of Spark are Python, Scala, Java, and R. They're officially supported. I mean, there are a bunch of another non-supported languages like Kotlin, like .NET, and they all are awesome. But I have discovered very quickly that sometimes I need the things other languages can provide me with. For example, the most popular language in data engineering, according to JetBrains research, is Python. And Python is really awesome. I love writing in Python. Data engineering was my first job where I was writing in Python, and it was a nice experience. It was very easy to start, and it was very easy to understand. But let's look at real code of simple Spark application written in Python. Okay, we have some imports here, like data frame and function SF. Then we define our structure. For example, we have structure of two fields, pk of long type and AA of string type, and we don't really care what is the real meaning of these fields. And then we need some transformation. We add column or JSON object where we call some weird thing like f dot get JSON object of f dot call JSON value and then $data. It's not quite obvious what is going on here. And furthermore, we are using literal f, which we are not sure. Well, to the reader not familiar with usual PySpark approach, he doesn't understand. They don't understand what f literal is. And then we are raising one more column, which is part struct, where we call f dot from JSON of f dot call JSON object. And here we are reusing our data type. Of course, we know what does this mean. We are really just adding two more columns, and in the second column, we are really parsing JSON in some predefined data structure. And I forgot to add one more selected. And then we are just, selecting the last column, which contains our structure. So what did we see here? We did see here those weird f literal, which is made to distinct Spark built-ins from some self-made functions. It is a side effect of a lack of type safety in Python. For example, there is function in Spark called regex extract, and there is such function in Python itself. And Python won't be able to distinguish these two functions without those f literal, but it looks completely alien. And when we are speaking about other functions, did anybody at any time create their own function to not clash it with Spark and to use f literal? Then API is untyped. I mean, of course you have some structure and you have a definition of types used in this structure, but it is not type checked at compile time. And it means that it's very simple and easy to make some mistake and not be able to fix it quickly because Python won't say you what gone wrong. everything is string-based. This is the fact I don't love about most parts of string APIs at all. Because, we have some smart programming languages not to use some string literals. We have fields, columns, and so on. Why can't we use them? UDFs written in Python are usually slow. Not all the time, but usually they are slow because Python processing of any row involves passing data from Java to Python, and this is slow. And then processing in Python, which can be slow too, but maybe very fast because it may be done in like C or Fortran code, then it will be fine. But still, passing data from Java to Python is slow. And it's complex thing to support, complex custom data type. For example, you have your very own data type, something like data class in Python. How will you support it? You need to write a bunch of code in Scala and bunch of code in Python, or you need to pass to transform all the data to JSON and then parse it in from JSON, which both are very slow. And let's look into architecture of Python JVM interaction. There are quite a bit slow parts. For example, there is Py4j on master, which contains Spark context in itself, but it's Python process interacting through socket with Java process. And in cluster, it will be even slower because Python processes will interact with Java through pipes, and pipes, to be honest, are not too fast. So PySpark performance is, debatable too. And let's look at this. There are some problems with syntax in Python. Spark is very chain-based. Spark DSL is very chain-based. We are writing chained calls everywhere. And sometimes, and we have two options actually. First option is to, bring everything into brackets. And the second option is to write backslashes everywhere. I don't like both because they, it becomes closure or it becomes bash. It should be written easier. And then lambda syntax in Python is not quite convenient too. We have very simple examples here with lambdas with one argument, but what if I have two arguments in my lambda? It becomes a little more complicated. To be honest, I don't even remember the concrete syntax of lambdas with two arguments. Okay, we know that everybody knows that Python is not too fast when it's working with Spark, but Scala is extremely fast. And as of me, it's the best official API. I'm not sure that there is official rating anywhere, but there are both typed and untyped API. You can mix them. You can use good parts of both and not, use bad parts of both. It has awesome smart encoders. I mean, it will encode almost anything you can put into case class. Spark is written in Scala, and it is the warranty of the best interop possible. It means that it's easier to call anything written in Scala from Scala, because if you'll try to call, some implicit thing from Java, you won't succeed. You will need to, write some bridge or something like that. And of course, it has huge ecosystem, which is awesome. But there are hard parts in Scala too. For example, look at this snippet. I won't highlight anything specific here, but look at def add x colon int, y colon int, implicit z colon int. It's simple method, but then it's defined in inside another method called add2, and then we are calling add_n, and what is interesting, we don't have variable z here, we have a variable z1, and this code really works. It looks like a magic. Where did this z came from? What if I will redefine it? Will it change behavior of my code? What if I will add new variable like z2 in some another place? What will be implicit value of z2, value of z1, or value of z2? It's interesting question, and to be honest, I'm not sure that I know correct answer. Oh, let's look at type system. For example, we have trait hash set with weird signature plus t, and yes, it has some method like def add of u greater than :t, accepting something of item of type u. Well, to be honest, it's hard to understand. And I'm not sure that, of course, we know what hash set is, but imagine it will be something like this. Create Zalimba and go there. What the hell is going on here? I'm not sure I can understand what's going on. I don't know what Zalimba is, because it's not something from TS 101. So yes, Scala is awesome, but sometimes it's hard. It's hard to learn for people without JVM knowledge. I believe that it's a good idea to know Java before, learning Scala. It's very simple to write the code you won't be able to read in 1 month, and team members won't be able to read it tomorrow on code review. And because sometimes it's hard to read code somebody else wrote. And it's very easy to abuse language features. Operator overloading, you can overload any operator, anything. And sometimes it's awesome because in Spark, it gives us awesome readability of our code, but it's very simple to abuse. Implicits are implicit. They're not obvious. And sometimes it's hard to understand how will it work. Traits is concept quite alien to JVM world at all, because you have either interfaces or abstract classes. What trait is? Is it some interface with state? I'm not sure everybody understands. But Scala's type system is really awesome and powerful. Really awesome, because you can do anything in this type system. But even Spark doesn't utilize its full power and for a great good. Consider this example. It's some real code from Spark, from Scala reflection. Here we are creating something called new instance and passing there some class plus arguments of this, constructor call. Object type, which is something, and propagate null. What propagate null can be clear if you know how null propagation works in Spark. And then we are creating new expression if, and passing the 3 arguments, is null, some literal created with object type and new instance. Okay, we all know that if is expression, but sometimes we just can't type check it in Scala. New instance, object type, if is null, literal, they all are just expressions, and they are usually not type checked. So you can pass any expression inside any expression, and it will compile but won't work. And it causes a lot of debugging when you're creating new JVM API for Spark. And finally, let's talk about Java. Well, Java is, verbose. I need to have lots of lines of code to define 3 fields, hash code equals. in Scala, I can just write case class and 3 fields, and that's all. No getters, no setters, no hash code, no equals. And when it comes to working with Spark, we should define encoders everywhere, on every step. Even for int, we should define encoders. For example, Spark create data set from list of ints requires us to define integer encoder, which is built into Spark itself. And on every step where we are getting new type of object, we should create a new encoder. It's very verbose. Java is very verbose. And yeah, the last but not least is R. Well, R is hard. For example, this is very simple code written in Doppler with Sparkler, which is one of possible solutions to work with Spark from R. First thing, we are copying something to something, like, of course, we are copying some empty cars to Spark context. And then we are calling this weird thing. It's not bad, but it's not understandable by mere humans, because what is percent greater than percent means? Yeah, it's pipe operator in Doppler, but you should know it. And there are ideas on deprecating Spark R, which is official language, our language support in Spark. And there always will be performance gap between native, I mean JVM here, and other languages, because you need to pass data somehow from JVM to some other world, Python, .NET, R, anything. So let's talk about Kotlin. Kotlin has awesome thing. It has null-aware type system, and it means that you can know at compile time if something may be null or may not be null. And it has extension methods. For example, we can add to any iterable of int, we can add a method sum, which will work with reduce, fold left, or anything like that. And of course, such method already exists as a standard library of Kotlin. But let's join these things together. Consider following snippet. For example, we want to have left join in our code. It's payment.join on some sequence of customer ID, and then left outer string. Again, string-based programming, it outrages me. And then a bit later, we are calling something like .map _to.id. And what will happen? Of course, null pointer exception will happen, because Java has unique exception for everything. And you will waste a lot of time to understand where this null pointer exception came from, because Spark doesn't give you such information. It will be something inside generated code, which you is unable to debug, actually. You can print it, but it will be very hard to understand. And again, you will be unable to debug. In Kotlin, we can do better. First, let's replace left join string with left join method. It's just extension method, nothing special here. And then we are, joining with customer on column customer ID. And then we are calling .map it, which is like underscore in Scala, .second.id. And this construction won't compile at all, because left join method knows that second part, right part of join may be null during left join. So you will have to change it to it.second .id, which may be null, and it means that you know that there may be null. And on the next stages of your pipeline, you will have to check again if it's null, and maybe change, maybe set up some default value there, or maybe something else, maybe even throw exception. But at least you will know where did this exception came from. And let's talk about the self-building capabilities. We don't have much time, but consider this snippet. We have some function HTML which accepts any function defined on HTML class and returning HTML. Then inside this method, we are instantiating HTML class, calling init on it. Init is again argument which came into our function, and it may be extension method or built-in method of HTML. We don't care. It's how it works. And then we are defining new method, extension method, called h1, which obviously will create header of level 1, which will call some method at element, which is not here for brevity. And then we are building very beautiful HTML DSL. It's Kotlin XHTML actually, and small snippet from it. HTML, which contains only one header with text example. How can it be used in Spark? Easy. For example, did you ever see the troubles with caching? You're caching something, then you forget to unpersist this cache, and your job fails because your memory or your disk ran out. Here, we are defining new extension function with cached. At the start of this inside, curly braces block, source dataset is cached. We can do anything here without recounting all the pipeline many times. And after last curly brace, it will be unpersisted, which is awesome. Of course, you can define should it be unpersisted synchronized way or an asynchronic way, but actually it works and it's very simple and no more errors here. For example, what about Spark? Do you really want to create Spark session, create and so on and so get to create and define options on it? You can use just with Spark function, which is just extension, just simple function which inside which we have something like DSOF, which is method to create data set from list. And you can pass new things there. For example, I have redefined log levels. They are not strings, they are enum now, and you can pass any properties there. And of course, left join and so on will work here. And pay your attention to this .eq. We can't overwrite double equal sign in Kotlin if there is equals on object defined. So we are creating new extension method called eq, which is quite native. Lots of people know what does it mean. If you have some corporate standard of Spark session, it's preset with Hive and everything else you need. We have another function with Spark which accepts builder as argument. Still, you can redefine log level, and inside you will have all these neat functions and all these neat extension functions. So what are the benefits of Kotlin for Spark? It's very easy to read. We don't care. It's easier to read for Python developers, for Scala developers, and for Java developers at least. There are no encoders. It's magic built into the library. It's null safe, and you can win from it when you're using joins or something else, where you can tune or manage null safety. It has extension methods and DSL helpers. It has a very Scala-like API, no more encoders like in Java, and it supports dataset API, which is typed, which is strongly typed, I mean. You have option to opt out from any non-native experience. If you don't want to use with Spark, just don't use it. Call Spark session, get to create, and work with it. If you don't want to use with cached, don't use it. Just call cache, define options there, and use it as you love. And of course, it's strongly typed, but we have strong evidence that Python developers are find it easier to use Python's types in Kotlin. We have several things to improve. It's ML support. We don't have it right now. Maybe we should create better syntax for UDFs. Please give us feedback on our GitHub. We need more audience. We need more extensions. And maybe one day we have to support Scala 3. Final slide. Please visit our GitHub, JetBrains/Kotlin Spark API. It's official JetBrains project. So even if something will happen to me, Kotlin Spark API will be supported. And give us feedback. Give me feedback in my Twitter. Give us feedback in our issue tracker. Thank you very much. It was Pasha Finkelshtein, developer advocate from JetBrains.